Okay, so hopefully you filled in your chart. In the x direction, a is 0. Acceleration in the y direction is 99.8 meters per second squared. Time was 0.57 seconds for both. The x direction we found previously to be 1.3 meters from the table. That's the range. The height of the table technically was negative because the origin was from the top of the table and it went down 1.6 meters. The initial velocity of the car being flung off the table only occurred in the x direction, and it was 2.3 meters per second. And again, it does not change in the x direction, so those initial and final velocities in the x direction are the same. This one is a concept. You have to know that. You have to know that concept. Okay, I'll put the word concept down. Concept. You have to come with that information. And now, hopefully, you've worked out how to solve for the v final in the y direction, which was you were going down at negative 5.6 meters per second. Now I'm going to show you how to do 2D and 2E. All right. 2D, what was the final direction as the car crashed into the floor? So I'm going to draw like maybe a car crashing into the floor, right? No, normally they're made so strong. Alright, so that's the floor. And that's the car hitting the floor. And for one split second, this is the impact. Now, technically, you would kind of know it's going to go like that for 1 second. But we don't really know that right now. All we know is the velocity in component forms. You know, this, in the y direction, it was pointing down, was 5.6 meters per second. That was v final in the y. And we also know this, v final in the x direction. V final in the x direction. V final in the x direction is 2.3 meters per second. Now, in order to find the final velocity of this car, this velocity of the car, we have to do some kind of idea of head-to-toe movement. So we take this vector, which I don't know if I can move it. Can I move it over? Yeah, I can. And put it right there. Right there. Will it go? Yeah. Now I have head-to-toe idea. And when you have head-to-toe with two vectors, I'm doing this one and this one, you can now draw this vector. Alright, so I'm going to clean this up, so I don't want that here, and apparently I can't erase it. So here's my car. I had two vectors. I had a vector going this way. Now I had a vector going this way. So one of my vectors says 2.3 meters per second. The other vector says 5.6 meters per second. How do I solve for this vector? It's Pythagorean theorem. So it's a squared plus b squared equals c squared. This will be my v final. So my v final is equal to the square root of v final x squared. I'm going to get rid of this up here. Plus my v final and my y squared. If you plugged in your numbers, you would get 2.3 meters per second squared plus 5.6 meters per second squared. Don't forget to square root your final answer. Your v final should be, and I'll have to write it over here, my v final is 6 meters per second. And that little trolley thing just from shaking of the projectile. Of the projectile screen. Alright, there you go. Alright, but this does actually solve us for 2E. So here's one of the answers. 2D. Checked off. Alright, now we got to get to 2E. If I can erase all this. It takes forever. Fast forward this section. Alright. Well, come on. Fine. Alright. 2E says, how do I find this one? Alright. So, here's one. This is 2.3 meters per second. Remember, the car is coming down here, so here's your car landing, you know, a car with some wheels, all right? This is the car landing. Then, technically, it goes down here, but then I drag it over. So we had 5.6 meters per second, and I want to find the angle of impact. So I'm trying to find the angle that makes this angle. So what is the angle from the fall? Did the car come crashing to the ground? So draw a picture, label the components, the final, the resultant velocity. Here's your resultant velocity. There you go. And then you got to find that angle. So the best way to do this is to know your trigonometry. So theta would be, if you took this relationship, opposite over adjacent. So, opposite over adjacent. I need room to write. So, now I can write, what's my opposite? My opposite is this number, 5.6 meters per second. What's my adjacent to this angle right here? It's this number. So it's 2.3 meters per second. I didn't need room, so I got to erase. Seriously, this is like taking too long. I'm sorry, guys. Alright, so now if I have theta, well, let's before I get started, let's do tan theta is now equal to the division of those two numbers. 5.6 divided by 2.3. I crossed out the units. How do I solve for theta? Theta is a trigonometry trick. You would go inverse tan. Don't forget to look for that in your calculator. This number, 5.6 divided by 2.3. Theta should be equal to, if you plug it into your calculator correctly, 67 degrees. Done.